This is applications for our paradigm reactor system. So real world performance data focused on a couple of different markets where we've been measuring results working with our customers. Public transit is one of a number of markets that we serve. We'll talk about some of the other markets. All of them have very heavy duty fleets that use heavy duty engines that we can help decarbonize. 90% of the universe is made up of plasma. That surprises most people when they hear that number. It's essentially a ionized gas that when you think about a water molecule, water can be a solid, it can be a liquid like water itself, or it can be a gas like vapor, or it can be that fourth state of matter, ionized gas. Again, plasma really is ubiquitous throughout the universe, makes up most of our lives today. We simply have figured out a way to apply plasma to help decarbonize emissions. Carbon soot, what is the problem that you guys face every day in your heavy-duty fleets? Heavy-duty fleets require very large power systems to be able to operate. They need diesel power for the range and the power necessary to drive their operations. Here's some examples of some of the customers we work with: waste hauling companies, utility truck companies, county governments that run large vacuum trucks like the one you see there, even electric power generators. Think about a power backup system. That really requires a large heavy-duty diesel engine to operate as a piece of equipment. Diesel is something that's going to be around for many, many years as additional power chains are developed and brought on stream. All of these fleets deal with this carbon soot problem that we're going to be talking about. Here's a basic diesel engine that you're all familiar with. Everything in color on this graphic are the pollution controls or emissions controls required by the EPA to operate this engine. These controls, they're really made into 5 major systems. They do a great job controlling the pollution effectively. They're also very expensive to purchase, include on the engine, to maintain. They also burn more fuel. They're made up of 3 basic categories: EGR, what we call after-treatment or downstream devices, and then SCR systems. They all play a specific role in helping to control the pollution coming out of the engine. The problem is they also are very dirty. Diesel engines produce carbon soot. Here's the kind of damage that you're all familiar with that carbon soot does to the very expensive, complicated components on a diesel engine. The net result is that you end up with a lot more back pressure on the engine, you burn more fuel, you end up creating more CO2 as a result of that. Of course, your maintenance goes way up. Vehicle downtime is a big issue especially for some of the commercial fleets. So if the vehicle is in the shop being maintained, it's not in the street producing revenue for the customer. Very strong environmental and financial impact by this carbon soot damage. The next question is, how does Paradigm use plasma to decarbonize the emissions coming out of the heavy-duty engine? We developed what is called the Paradigm Plasma System, which uses a plasma reactor to decarbonize the emissions. As I mentioned earlier, the net result for our customers is that we can reduce your fuel costs by anywhere from 6 to 10% when the technology is fully deployed. Your maintenance can really be reduced up to 20%. We believe we can reduce global CO2 at the gigaton level. Very dramatic financial and environmental impact by using our technology. We're protected by 3 patents that have been issued on the technology. It's very, very effective, exciting technology that we've been able to commercialize and bring to market. Just a quick comment on what carbon soot really is. Carbon soot is basically hydrocarbons. Most of it's hydrocarbon material that comes out of the engine. And you can think about it as a solid carbon sphere. They combine together in particle agglomerates with absorbed hydrocarbons. This is really the material that our technology goes after to eliminate in the emission stream. The way that the reactor works is that on the left-hand side, you can see that there's a series of what we call corona discs in the reactor. High voltage comes in here. It generates an electrical field around these corona discs. What ends up happening is the corona disc enhances the electrical field by a factor of 25. If we bring in 20,000 volts into the reactor, it really ends up being about 500,000 volts by the time it reaches this corona region in the reactor. This really aggressively injects electrons into the streaming. Think about it as an electron avalanche that occurs at this part of the reactor. We create an intense plasma region within the reactor, which is right here. As the emissions goes through the reactor, into the reactor right here, passing through the plasma region, we actually break down the carbon molecules down to their atomic level. They reform in the form of mostly water, a little bit of CO2. We've demonstrated through testing with companies like Ford that we can eliminate up to 98% of that carbon soot by taking it through that plasma region. You can think about what's happening in the reactor is that we have very chemically reactive radicals are created in the plasma from the exhaust gas constituents. These radicals, together with the electrons, attack and break down the carbon soot into these benign phase gases, like mostly water, a little bit of CO2. This is effectively the way that the process works. As I mentioned earlier, the basic science has been around for many, many years. Paradigm just simply figured out a way to commercialize it and bring it to market. Some applications for our technology on heavy-duty fleets. The first reactor we brought to market is called a Generation 1 product. It's currently being used in the EGR loop after the cooler. It can tolerate emissions temperatures up to about 300 degrees Fahrenheit or 150 degrees centigrade. That's our Generation 1 product that we're currently selling to heavy-duty fleets and decarbonize the emissions in the EGR loop itself. The next product we are working on, we received $250,000 from the National Science Foundation, a phase 1 grant to develop our next-gen technology that will be able to tolerate temperatures over 1,200 degrees Fahrenheit. Now we can use the technology before the cooler in EGR and protect all of the EGR components in this part of the engine, as well as we can use downstream at engine out, protecting the DOC, DPF, and a lot of the sensors and components downstream as part of the SCR system. The other interesting opportunity is that we can also use as a way to, as a cleanup reactor to go after any remaining nanoparticles that might make their way through the DPF. So this really attacks the fine particulate matter that is the most deadly size particle to human life. Very exciting opportunity for this next-gen technology we're working on. Then the final product, and this is really more of a product concept, we've experimented with combining plasma with catalysis. So we envision that someday we'll not be able to have one device that removes both carbon soot as well as NOx in the same device. We've done some testing at RIT in our diesel test lab. We know that we can effectively, at least at the engineering model level, create a device that does this. Again, exciting applications for plasma, both in the EGR, downstream, protecting all these components, as well as a potential for another product downstream, combined with catalysis. Lots of good applications, lots of versatility in the way the technology can be used. Some real-world performance data and results that we've seen working with our customers. First of all, we did some testing with Ford Diesel in their labs in Dearborn, Michigan. And here you can see that the reactor was installed in the EGR on this engine, on their engine dynamometer. We used a Ducati mass measurement analyzer to measure the amount of carbon mass before the reactor as well as after the reactor. Here are the results. You can see that they ran the engine at various load levels. They also ran the system at various voltages going into the reactor. You can see here that what's really most relevant to you as a transit company is when the system was measured at high idle and idle, we eliminated almost at least 95% up to 98% of the carbon soot that came out of the engine. Idle and high idle are very prominent loads on the engine for a public transit bus. This really tells us that the technology can be used very effectively for public transit operation. The other example is working with RTS, who's really helped us develop the technology. We demonstrated that we can eliminate up to 90% of the carbon soot in the EGR in this Cummins engine which I think is approximately about a 10-liter Cummins engine on those buses, 8 to 10 liters. Pretty good size heavy-duty engine. You can see visually the samples here. This is a raw soot, a sample taken before the reactor. And then after the reactor, you can see how much cleaner it is. This represents about 9% reduction. The third example is a heavy-duty truck that is operated by Monroe County. You can see here that the reactor was installed in the EGR system of this truck. They also use it on electric power generators. So not only vehicles in the county, but also electric power generators where they decarbonize the emission from the heavy-duty engine on that equipment. Here's a picture of typical components in the EGR. This is the EGR valve. Both of these are. This is the air intake. This is carbon sludge that's created by carbon soot going down into the oil. These are typical pictures of the damage done in the EGR system on that truck. When we were planning to install the system, we took a picture of the EGR valve before we put the paradigm system in. You can see how it's all clogged up here. After about 90 to 120 days, you can see that we took another picture of the EGR valve, see how much cleaner it is. So we really eliminated almost all the carbon soot that would have normally clogged up this EGR valve by using our plasma system in the EGR loop. The other thing we measured is the impact on the DPF regen cycle. We saw that over the course of between March and June 2025, that we increased the time between regens by up to 2.5 hours per regen. What that really tells us is that because we're having less soot clogging that down to the DPF, the DPF wasn't, the pressure sensors weren't lighting off as often. We actually reduced the amount of, increased the time between regen cycles on this particular diesel particulate filter. And that result is we calculated about a 9% less fuel burned and CO2 emitted. And we also had lower maintenance costs of the DPF as well as less wear on the DPF. So, and of course, the engine was in service much greater, so producing more revenue for the operator. A lot of people question, okay, what is the impact of our technology on some of the new powertrains that are coming downstream? And, you know, Paradigm positions into the market a very strong existing infrastructure and strong supply chain. It really work with internal combustion engine fleets as well as manufacturers to implement our technology. And we can have an immediate impact on CO2 reduction as well as cost of fuel and maintenance reduction. While these other powertrains like electric and hydrogen that have been talked about quite a bit this week are still being commercialized. The bottom line is that diesel is going to be around for many, many years, and our technology can be used very effectively to impact CO2 and reduce maintenance and fuel costs on those engines while these other powertrains are being scaled and coming on stream. A good example is the work we're doing with RTS. And you know, Rusty and his team have implemented both electric buses as well as buses, but they're also staying primarily with diesel powertrains as part of the main part of their fleet. And so they're planning on using Paradigm as part of the technology for their diesel fleet while they're still working on some of these other powertrains. We can Paradigm is part of the on-ramp to the highway of the future. If you think about the highway of the future, you've got various powertrains like hydrogen, electric, gas, diesel, and Paradigm plays a key role in helping to decarbonize that highway as these other technologies are being developed and scaled and coming on stream. So it really has a very effective role in the future of that highway. So again, you know, we've really seen that Paradigm technology does a terrific job of decarbonizing heavy-duty emissions, and we've seen it through working with our customers, by measuring results, by working with the OEMs like Ford and Corning. We've done testing with Corning because, of course, they make diesel particulate filter substrates, and so they've really seen some very effective results too. And just excited about the future for the company, but don't take it from me. Let's hear from some other folks in the market as well as some of the experts in.
Here's what it looks like when the exhaust goes through a regular diesel engine. Here's what it looks like when it goes through Paradigm's new system.
And why does all this matter to you?
Through this whole process, we're also reducing CO2. because the more fuel you burn, the more CO2 you create.
So for all of us, it makes diesel engines cleaner and better for the environment. For trucking companies, it could save millions of dollars in maintenance.
The Regional Transit Service in Rochester has been a part of the pilot program for about 8 years.
It basically cleans the air before the exhaust even hits those devices, so it will greatly improve the life of those components. You're saving money in parts, you're saving money in labor, and you're reducing fuel consumption at the same time.
For the company, looking forward to working with all of you in your operations to help decarbonize your fleets and, of course, save you a lot of money in maintenance of fuel as well as reducing CO2. I'd like to invite you to join our, we have our technology installed on an RTS bus in the exhibit hall, so would love to have you join us over there. I can actually do a demonstration for you on the tech. So, and now I'm happy to answer any questions you might have.
Yep. How small do you scale it? You do like a Volkswagen diesel?
Sure, it's a great question. So the technology is very, very easy to scale. And I were talking earlier about, as an example, I think some of the electric buses use diesel heaters on them. And so, yeah, we could scale the reactor down to a smaller diesel engine like that. We're also working with heavy-duty trucking trucking companies that use what are called TRUs. These are units on their trailers that use diesel engines, and you can really apply the technology, make smaller ones, make much larger ones. They all effectively use the same power supply. So, question though.
To create the plasma state, how much electrical energy do you need? Do you have to supplement the electrical supply?
Another good question. And so, the power supply we use produces volts, all right? And we deliver 20,000 volts into the reactor. It's only at about a 2 to 5 milliamp level, all right? And so when you do the math, it's only like 50 to 100 watts of electricity. So it's not really drawing anything on the end electrical system very much at all. So it's like a light bulb, the amount of current in a light bulb inside the reactor. So, question. Anybody else?
Requirements and looking at the photos, the kind of standard repair or installation time regarding what you have for the transit that you're doing with Rochester, kind of what's the labor cost to actually do the work?
To do the install, yeah. So we estimate probably about a half a day for the first one. So it's a really easy plumb. If you come out to the bus, we can show it to you out in the exhibit hall. So it's easy to plumb it in to the piping system, and then the electrical connections, we just take switch to unswitch power from the electrical system on the engine. That's an easy connection, and then we also have a one-way communication with the ECM. We pull down some J1939 data, so it goes pretty straightforward. Yeah, Greg.
So the fuel savings, do they come from just running the doser less often, or is it because the internal circulation makes for a cleaner overall burn?
Yeah, both of those, plus because in the industry, you know, there's a term called fuel penalty. And the fuel penalty really primarily comes from the amount of back pressure that carbon soot creates on the engine, all right? To create more back pressure, the engine has to work harder and burn more fuel, right? By eliminating almost all of that carbon soot and back pressure, we estimate about a 6 to maybe fuel savings, 10%, something like that. So,
does the reactor require any periodic maintenance once it's in operation, like a cleaning cycle or anything?
The reactor is made of, it's all stainless steel, there's no moving parts, and there's some material in there, ceramics. So it's all very durable material that doesn't really require any replacement or maintenance. There is one wear part, it's the high voltage pass-through. It's like a big spark plug that delivers electricity into the reactor. And we anticipate replacing that once every maybe 9 months, something like that. But that's really the only replacement part that we envision. The other thing that could break down would be the power supply. That's typically infant mortality, and we just replace it under warranty. So,
does the unit last as long as the bus?
Well, you know, we haven't done life cycle testing on the technology. It's new enough that we're still figuring all that out. Because it's very durable. It's all stainless steel materials. You know, it's really going to endure. There's really no filters or anything like that inside that has to be maintained. So,
Zero emission transitions ONL program this year, the administration seems to have loosened up what funds can be eligible for fleet replacements.
Yep.
Have you had any discussions with federal representatives or APTA on funding this type of conversion for diesel fleets?
I have not, great idea. I have not directly, but maybe you can mention one of the initiatives you're working on.
Yeah, well, no application for this year. We applied for $24.2 million for primarily phase of a part of the hydrogen fueling station, but to make the application a little more attractive, I threw in $1.2 million for 106 of these units for our diesel buses because they're encouraging more low rather than no. So I threw that in there to kind of make it a little sexier. So we'll see what happens.
Yeah, a lot of people ask us, what's the impact of the new administration on our technology and our business? And my answer, it only helps because it's rebalancing going on back towards fossil fuel investments, and that's really where we shine, helping our customers.
What Rusty's talking about, if you're doing something like this, you need to capture the credit for it.
Yeah.
Because we have a state mandate and then there's a federal program, so making sure you're capturing credit on things like this that are working towards those goals.
Yep.
Losing that credit.
Great idea.